Let me do this. Okay, people. That's for you, much better. I'm not sure. It's not like to me you like it. Is it okay? You see what you're actually. But now it's better you see what's going on. You see, don't tell anyone that I actually stole the cable from the scripture. I don't think I'm supposed. But it worked, so let's do that. Let's start our first class. Look at that. Coordinate systems. This is literally you opening the door to the wonderland. And it's not a joke, it's true. This is completely new idea that we were doing everything in 2D, like a caterpillar walking on a table. And that's not how we build things and how we live. We live in 3D, and there are even more dimensions than that. So it's time for you to learn upper dimensional mathematics and science. So that is pretty cool. To be honest, that is pretty cool what you're gonna learn today. This is a funny joke from Dr. Pian. What's up goes up, right to the right, and front x. That is not an international notation. Surprisingly, there is different notation for these axes, and usually in Europe we do up, to the right, and to the left, like so. So looks this. Oh, I mean this. This is the one which is weird. So you will see either this notation or the one in the book. This is the one not from the book. This is the notation usually I was taught. So as you can see, you draw to the right your positive y. Front, you breaking the third wall here. Front is x and up is z. 3 dimensions, looks very natural. This is how we see this room. So what do we know? We know that this floor is where we've been studying before. Floor is lava, which means it was calculus 1. You see, the floor is x and y. That's what we studied, how to find equation of a tangent line, parabola, what is ellipse, and so on and so on. Remember, optimization problems, everything was on the floor. So we were like caterpillars, learning everything on the floor, and actually there is height and depth up and down. So now we're taking everything in 3D, which is an amazing idea because we know how to draw a line from this point to this point in 2D, and that is a line. But maybe it's a shadow of some beautiful shape, like a plane. So we were restricted by our imagination before. Now we're gonna take it to 3D. Isn't it pretty cool that we did not see the full picture? Everything we learned, all the parabolas and circles, they might be projections, that's the official term, or a shadow of some kind of beautiful shape in 3D. So that's how cool it is. We were working with shadows of the clouds, and there's a beautiful cloud in the air. So we need to learn how to work with that. So let's plot some points. To plot points, for example, let me see if I have it here. Oh, let me define first. So this is why there's a caterpillar. Caterpillar was on the floor. We know how to do things on the floor. How to do things in 3D. If I give you a point A, B, C, how to draw it? A is your x-axis. So you go from 0. As you can see, the coordinate system has a center, 0, like it always did. And all 3 lines are perpendicular to each other, like we had before. You first go towards x, that is my A. A units on x, positive or negative direction, depends what A is. Then when you finish doing that, you see that, so x was A, that is red, green is y, green is y, y is B units. So I'm going towards y, you see, not on the y over here. I'm going at a different location because x already moved me. B units to y, positive or negative direction. And finally, z is the new thing which we just see for the first time. Let's do it purple, z. That is up or down. If c is positive, we do c units up. And this is the final location of the point, A, B, C. So if you do it step by step, it makes sense. This creates, as you can see, a shape. And this is what usually we imagine cubes when we work with this or so on. So whatever used to be in 2D, which was, if you remember, a rectangle, now goes to 3D. So basically, it is just a shadow. It used to be a shadow of a 3D object. Let's practice. I have 3 points here. And you see, this shape of the coordinates does not look the same as the one I showed first. Somehow in this book, they like to open this angle more towards us. It is a right angle. While in general, we actually were taught in Europe to do it like this. It's not like so, if you see the difference. We kind of were taught that y should go directly to the right, x towards us, z up. So let's practice 3 points. 1, 2, 3. I have it here. A. 1, 2, and 3. Let's repeat what I just did. 1 means I'm starting at 0, and I do 1 unit, it's positive, towards positive x. So I'm going here by 1. Now I need to go 2 units towards y, that is to the right. So over here I will change the color to green. I will do twice more, like so. So it's over here too, but I'm actually shifted because x already shifted me a little bit. And you see I'm going parallelly to the axis. Finally, 3 units up, that is z. 1, 2, 3. So this is the final point. See? Does that make sense? 1, 2, and 3. 1 step in x-axis, 2 steps in y-axis, and 3 steps in z-axis up. Can you do it yourself? Does it make sense? Let's do one more with negative, and you tell me what to do. B. What do we do first for B? 2 towards us, right? Front. So I'll do twice more over here. That's 2. Now what?
2
to the left. Why?
Because it's negative.
Negative, right? So I'm going here, right? And I'll do it a little bit more. 1, 2. And then up or down? Down. Only 1 unit down. See? So it should be kind of corresponding to the units, if you can do it. That is 2 minus 2 minus 1. Does that make sense?
Yeah.
Yeah?
Do we always plot it as we read from like left to right?
Yeah, kind of. At some point you will get good at it. So z means height and y means to the right. But if you do it in order, you will mess up less. Yeah, I would say that. You will get intuition behind it later, but I will recommend you to do it in order first. So that makes sense. I think that is good. This is an interesting thing, and we're going to be using hands a lot in this class. Rotating things with hands. You know, if you take physics, they do it quite a lot. But it's funny that it is international. Can you imagine that we are doing this trick with hand right now, and at the same time with you, in Japan they do it, and in Austria they do it, and in Croatia and so on. Same trick everywhere. So the thing is, how do we know where z goes up or down? Because if you take, if you take this graph and flip it upside down, you will still have x and y on the floor, but z will be different. So people had to kind of agree, wait, in 3-dimensional, apparently it matters how you look at the plane, like this or like this. Soon we're going to learn that planes have surfaces, and surface direction will matter. We're going to learn this in the months. This way or this way. One might have different direction than another one. So it was created the idea to use right hand rule, sum up. So left-handers, we always get confused. I always do it wrong because I haven't finished to use left hand. Right hand, you're supposed to have, so these 2 fingers will show you. You're supposed to curl them when the pointing finger goes towards y and the index finger goes towards x. Whatever the big finger shows you, sum up, that is the positive direction of z. So this is obvious from this picture, but it's not obvious if it's like this. What if all this system is kind of having the angle somewhere? So like you see this flag, what if this flag is z? How do I know like where it's positive or negative? I'm using the same idea. I'm kind of like locating x and y, turning. Oh, this way is positive. So turning. And also there's one more explanation without turning. One more explanation says, or just look that your arm is y positive. Y positive is where your arm is. This is your arm. When you fold, the index finger should go to x positive, then still sum up gives you positive z. So what is going to be wrong if it's negative? If I'm using left hand to do the positive direction, I have to flip it upside down, you see? then it will work. Then left hand will show me positive down, and that's why left is not work here. It should be right. That's fine. We're gonna have more tricks like this, and it will be even more confusing for leftists later. So welcome to these struggles. This is very nice explanation. I always try to show you that whatever we're seeing is literally a room, actually many rooms, and I will ask you soon how many. Floor is where we used to work all the time. Parabola, let's find the closest distance between parabola and line. It was all on the floor. Now you have walls. You have right wall and left wall. As you can see, we have 3 walls here. Floor, right and left wall, each created by X, Y, and Z. This is how it looks like. So, this is a more confusing way to see it. And this is where we're supposed to teach you to draw all of these things. Can we learn? Let me see. Yeah. This is the beautiful picture, which probably will be hard for you to recreate. That's why I found an easier picture. This is the easier picture. So, X and Y, which is the floor, creates XY plane. XY plane has an equation. So let's draw the equations. 3 equations here. XY plane. Planes will have equations. Just like a line, x equals 3. That used to be a line, 3 units on the x-axis. Now xy, we're adding one more variable, xy plane. That means there is no height. That means z is 0, as you can see. And it's always like this. Whatever variable is missing, that one is 0. Make sense? So xy plane, usually we do yz plane after this. YZ, who is missing? X. X is 0. And then the last one is XZ plane. Who is missing? Y is 0. And that's how you should imagine. Everything is in 3D unless you start shrinking the wall. So for example, if I want to look what is XZ means, it was in 3D and then I start destroying Y. Y is this depth to the right and to the left. So I'm kind of using a tool, a machine, and then I shrink it, and collapse. And this is going to give me XZ plane. That makes sense? So we're going to be exploring what are the shadows of 3D objects. Say there's a watermelon on the floor. What is going to be a shadow of the watermelon or slice of it in this XZ plane? That's going to be the slice. So we're going to have to learn how to identify those slices. That is what you call octants. The first octant is the most famous one. Remember we had quadrants, now we have octants. That is the region where x, y, and z are positive, which is the analog of the first quadrant, but now in 3 dimensions. The first quadrant was here, if you remember. Positive x and positive y used to be first quadrant. Positive z means going up. That's first octant. How many octants do you think we have here in 3D? 6, 3, or 8? What? 8. There are a total of 8 octants in 3D. Let's check. Octants are boxes. Or I also like the explanation of rooms. I saw it online. So you imagine this is a multi-rooms house, like this classrooms, right? This is one classroom. There will be another one over here, right? That's another one, another box. There will be another one with negative x, right? There will be another one down, and also left and right. So total 8. Which means each side can be negative, so that adds one more cube. Now, if we have these planes, first octant, there are a total of 8 octants in 3D space, then I wanted to tell you that not only the point can be written when I give you 1, 2, 3, but point also defines all the shadows and locations on the floor and in the air. For example, if I give you this point, now call it P, A, B, C, right? Like so. Then, what are all these points? So let's practice if you understand this. This point, right? Do we know the coordinate of this point if we know that this is ABC? Yes, because it defines all of them. Any open seat? There's open seat over there. So, oh, you have a question? Oh, there's. I see. So, what do you think? Oh, yeah, you want to answer the question?
Yeah.
Yes. What is the answer?
The answer is going to be A, B, and then C will be 0 because it won't be defined by the Z.
A, B, 0. Agree, disagree, or want to add? What do you guys think? Looks good because A and B means how many steps I stepped away on the x-axis, and it looks like it's positive. B means how many units I stepped to the y-axis. C means how many units I jumped up. So I used to be here. Now when I fall down, like you see what I mean? I'm crashing to this 3-dimension into 2-dimension right now. If I'm doing that, it means I'm crashing the 3rd dimension into 0, so there's no 3rd dimension anymore. The third coordinate should be 0. How about this one? What do you think? What are we crashing here? So if someone said A, then what?
0.
So we're crashing 2 different dimensions now, right? Kind of, if we stepped away over here by A units on x-axis, but then we never stepped away anything else, that means this dimension, which is y dimension, is crashed, and z dimension also crashed. That's why it gives you 0. Make sense? Imagine they give you a shadow. That's I like teaching it as a shadow, which we call projection. This point gives you projection down as a shadow, but also here, like so. And the projection here will be just A, 0, 0. Let's finish others. How about this one?
0,
0, 0, 0. Good job. 0, B, 0. Same thing. We have projection on y-axis. You see, it's like so. It's literally projecting. It gives you like pew shadow. But other dimensions are being collapsed, so we don't have them. How about this one?
That'd be 0 BC. 0 C.
Why do you think it's 0 first?
There's no because the x-axis it's not the origin on it.
Yes. So we did not step away on the x-axis, right? Then what do you think now? B and Z. So I definitely see Z because it seems like it's lifted up. That was the first thing I noticed, right? It was flying in the air, so probably Z is not 0. Then I noticed it was on the right, so probably B is not 0. But I also noticed that we are on the ZY plane. And as we mentioned before, on a ZY plane, whatever is missing is 0. X is missing, so X is 0. So that's also the way you can see it. Either you see it geometrically if you have good imagination, or you see it algebraically. You can see the plane, then Z should be 0. How about this one?
0, 0.
No step, C. Thank you, and this one should be C. Right? All agree?
Yep.
We did not step away, but we lifted up. Last one, this one. So let's see, we stepped away by X because it's in front of me over here, that's A. We did not step away anything by Y, so that's 0. But it seems like it's lifted, so it's C. Good job. And the hardest one is this one. Good job. Does that make sense? So 1 point defines the whole octant. How crazy is that? 1 point defined the whole box, whole FedEx box size, if you think about it. How interesting is this? And this is how it looks like in a beautiful projection. You'll have it in your notes. I will share all these PDF files with you. So that's exactly what we just did. All these points just defined by this step away by A, this step away by B, and lifting up by C. Now, what do you think what x equals 3 is then? If we just did all the planes, what x equals 3 might mean? So in 2D, we know it's a line, but what is in a 3D? It's a plane, and someone even immediately thinking, oh, it probably connected with YZ somehow, right? So in 2D, we remember how to draw it. Just let's review. This is the floor, and then x equals 3. I'm stepping away by 3 units to the positive x direction. That's a line. So y is everything you want. Y actually is not 0 here, as you can see. It's 5, negative pi, 17, 100. But in 3 dimension, this is a shadow of a plane. So I will show you some cool tool I have here. Look at that. How cool is that? That is Surface Pro. I like it. So if this is y and this is x and this is z, then how do you think I should draw x equals 3?
So at the spot where y and z are 0, or no, just on the axis.
So x equals 3. I would see it like this. I'm stepping the same way I step 3 units to the right in 2D. I will do it here in 3D. Here's my 3 units here. And then it doesn't say to do anything else. So x is 3 all the time. So instead of having this line, this is what I have in 2D right now over there. You see? This red line is this red line, right? So imagine the floor. On the floor, you can see what I'm doing here. On the floor, I'm correct. It is a line which is parallel to y-axis. Here it is, parallel to y-axis. But now, not only y can be anything, z also can be anything, right? That means I'm going left and right forever and up and down forever. That defines a plane, which looks like a paper which you're holding in front of you. Kind of, that's all. Sometimes people write down x equals 3. Let me change it. So this is a paper that looks like this. That's interesting. So all those lines we learned in Calculus 1 are actually shadows of the plane. The plane is cutting through. If you are a caterpillar on this floor, you just see a shadow and you're like, oh, there's something in the air. But you cannot look up and down. You're a caterpillar. So you're just passing it by. But actually, this shadow is just a shade of a huge infinite plane or a piece of paper, right? How crazy is that? So that is pretty cool. That is how we draw in 3 dimension. X equals 3. Let's think about this. X equals 0 was a plane YZ. YZ is this plane that goes up. X equals 3 is a shift of this plane by 3 units front. So it takes the same plane and shifts its front by 3 units. Pretty cool. Same with other planes, of course. What do you think will be the equation of x plus y equals 4? What is that? X plus y equals 4. So you should think about that. Let me see. What is missing? Z is missing, but it doesn't mean it's 0. So you have to be careful with this. There is 0 there, which is x plus y plus 0z equals 4. And soon I will show you the general equation. That means z is not 0. It's multiplied by 0. That means z can be anything. Z can be 17 pi 3005 and so on. So did you try to imagine what x plus y equals 4 in 3D? You can draw this line in 2D, right? We know how to draw it in 2D. And then you just raise it up and down forever because z can be any. Z can be anything. How will it look like? Here's the answer. Looks like this. Here's the, you see this Cartesian coordinate completely different from what we saw before. There are many standards how to show 3D coordinates. This is the shadow, x plus y equals 4 in 2D. That is the line. And now you go infinitely up and down. They're actually supposed to go down as well, like so. Because z can be anything. That means height can be anything. So it's the same thing. It's a cut, but with the angle. X equals 3 was a parallel plane. X plus y equals 4 is also a plane, but with the different angle. Make sense? Pretty cool. Finally, I will show you the equation. Let me see. Before distance. Here it is. This is what I wanted to write down. The general equation, no, not a sphere. Oh, it's not here. Yeah, I'll write down it over here. The general equation becomes this. AX plus BY plus CZ equals D. That is general, that is a general equation of the plane. Plane. in 3D. Whatever is missing is not 0. Whatever is missing is multiplied by 0, just like I showed you here in this example. X plus y plus 0z is 4. Just like in 2D, all of those things mean some kind of slopes, remember? So they mean, these numbers mean by what kind of angle are we rotating. D, it's a shift and more information also, but every time you see that one is missing, that means that variable can be anything. So, and finally, I will show you a quick thing, which is distance between points. That's the last thing to show. The distance between points, we know it in 2D. This is the equation in 2D, remember? X minus x squared, y minus y squared, and you take a square root. We know that from Calculus 1. So there's a whole proof in the video. It's very short. You should watch it. It's fun. I watched yesterday. It was interesting. And then the formula just expands into third dimension, very easily to memorize. That's a nice thing. Here it is. Look at that. You don't have to know more dimensions, but I really like that there are more dimensions. In 3D, we need to know this one. In 3D, it looks like this. X minus x, y minus y, z minus z, square, square, square. Take a square root. That is a distance formula. And as you can see, people actually figure out all kind of other dimensions as well. Pretty cool. Any questions? If you were not able to do the iClicker thing, I have a paper here. Write down your name. And please don't be late next time. On Monday, we're going to go... What? We're going to do one side. Have a good day today.
Is there just one iClicker? Yeah, but it's like 5 minutes after class. Okay, so we need a better room.
Oh, I asked.
No, but what you can say is, because this room is full to the brim, because we have 100 students, that you are wary of COVID.
Yeah, I told him. I said it's not safe.
Why not write my name for that?
Left handy. Yeah, I asked. Last weekend in the month though, and they said no. I asked. It sucks.
And are you putting extra credit on the paper?
Yeah, go. That will be the same thing. Same thing. I'm just the only new thing is the clicker problem. Hi, Jonathan. I see you. I'm there. Ready for work?
Yes, I actually had a few questions.
Just a second.
Actually, I had a few questions.
Yeah.
So, you were right over there. I was
He was doing calculus.
There is an order. I think just like when you go and then you go up there and do the same. But we can check on that again. Yeah, just post it there. Yeah, we're ready to help. It's time to post questions. It's nice if you post questions. Yeah, lost and found already. So fast.
Do you remember me?
Yes, of course.
Okay.
I remember even your voice. I've heard your voice, like I know his name. Hi, welcome to Arizona.
Yeah, I made it out.
You made it. Good job.
Hi, Professor.
Hi.
I just want to say I had your class last year too.
Yes. Welcome. Welcome. I miss you guys. Bye. See you Monday.
Are you going to put your notes on the Canvas again?
Yeah.
Okay.
Oh, let me turn off the recording. I even recording it.